Today we're going to be talking about mole and quantity conversions. We started this the other day, and we started talking about molar mass. So to review molar mass, to find the molar mass, we add up the masses of the elements in the compound. This is going to be in grams per mole. So let's try an example. And for the example, I'm going to use calcium hydroxide. All right. So why don't you stop the video now? I'm going to pause it and do the problem, and you pause it and calculate the molar mass of calcium hydroxide. All right, so I have 1 calcium for 40.08 grams, 2 oxygens at 16 each for 32, and 2 hydrogens at 1.01 each at 2.02. So that gives me 74.10 grams per mole. And that's going to be how I add up my molar mass. And then I showed you that you can set these up as conversions. So 1 mole of calcium hydroxide is equal to 74.10 grams of calcium hydroxide. So that's how we would use it in a conversion. All right, and then the next thing we did was I said, and I'm going to use calcium hydroxide as the example because we did these on the board. I said if I have 4.2 grams of calcium hydroxide, and I want to know how many moles that is, then I'm going to do a box like we did, right? The conversion boxes. I'm going to put grams on the bottom, 74.1. Calcium hydroxide on the bottom. And I'm going to put 1 mole on the top. And I do this because my conversion says that 1 mole is equal to 74.10 grams. So I can cancel my grams like that, and that leaves me with 4.2 on my calculator, 4.2 divided by 74.10. And I get 5.7 because I have 2 significant figures here. So I would get 5.7 times 10 to the minus 2 moles of calcium hydroxide. And we talked about this. What does this mean? We talked about this on Tuesday, and I said, so because we know that 1 mole is equal to 6.02 times 10 to the 23rd particles, we know this. And so what I said to you was, so what we would do is, this doesn't mean much to you, I guess, if you think that, but 1 mole is equal to this, so you could take 5.7 times 10 to the minus 2 and multiply by this number, and now you know how many particles, molecules of calcium hydroxide you actually have. But we'll talk about that later. So the next problem that we're going to do is we're going to take, that's important, we're going to take the same number, just for the ease of it, 4.2 moles of calcium hydroxide, and we'll convert it to grams. So I'm going to put 1 mole on the bottom because I'm using the same conversion factor. And I'm going to put my 74.10 grams on the top. And I'm going to multiply this time. So this time, I'm going to have 4.2 times 74.10 And that's going to give me 3.1 times 10 to the 2 grams. So that means that if I have 4.2 times this many particles, 4.2 moles, I end up with 310 grams of calcium hydroxide. So this over here has been, mass to moles. That's what we've been calculating here, mass to moles. Okay, now the next thing that we want to calculate is we're going to calculate particles to moles. And for this, we're going to use 1 mole equals 6.02 times 10 to the 23rd particles. Now, I know we started this, but I'm going to take a little break here. There is a something called the mole tool. So real quickly, this might help some of you. This is a good time to put it in here. It's a little graphic with the mole in the middle. All right, and so everything has to go through the mole. So here is mass down here and in grams. And to get from mass to the mole, we use molar mass, and it's in grams per mole. So to get from mass to moles, or from moles to mass, we're going to use the molar mass, and we're going to use grams per mole. To get to molecules, or particles, right, we're going to use Avogadro's number. So we're going to use 6.02 times 10 to the 23rd particles to 1 mole. And those molecules have a certain number of atoms in them, so we can use that too. We can go from molecules to atoms. Now, over on this side, for our mole tool, we can go to volume. And the volume is going to be in liters. And to do this, we're going to use 22.4 liters is equal to 1 mole. Now this is only at STP, which we've talked about before, standard temperature and pressure, and it's for gases only. And so we're not going to get to this for a little while. Okay? So you can't do that for solids. Now you may want to put this on your periodic table. That's what I'm thinking. All right, but this we'll keep referring back to this today. So right now we're going to go and we're going to do our next one, which is going to be moles to particles. So 1 mole equals 6.02 times 10 to the 23rd. You can't write this enough. Particles. And so here we go. If I have 4.7 moles of nitrogen dioxide equals how many molecules of nitrogen dioxide? So I'm going to start out with my 4.7 moles. My moles go down 1 mole, because this is my That's my conversion factor, right? So 1 mole goes down. And 1 mole of NO2 has 6.02 times 10 to the 23rd molecules in it. Okay, so 4.7 times 6.02 E 23rd. So I get 2.8 times 10 to the 24th molecules of NO2. Okay, but what if I want to go in the other direction? So if I'm going in the other direction, we're going to say, what if I have 1.8 times 10 to the 19th molecules of NO2? So now I'm going to do the same thing. What goes down? 6.02 times 10 to the 23rd molecules of NO2. And then what's going to go on top? 1 mole of NO2. So now, just like up here, I could cancel out the moles, right? Now I can cancel out the molecules of NO2. And I'm left with 1 mole. So I'm going to do my division. 1.8 E19 divided by 6.02 E23. And I get, I'm going to round this off, I get 2.99, so I only get 2 digits, so $2.99 plus 1 penny is $3. So 3.0 times 10 to the minus 5 moles of NO2. So that's how we do moles to particles. Okay, so here's moles to particles and moles, molecules to moles. So moles to particles, so moles to particles, and particles to moles. All right? Now, what if I wanted to do compounds to atoms? So if I had, for example, moles of, okay, let's draw a line here. Right, so those two things were the things that we were kind of working on in class. So those are the two things that we've already done. So the new thing that we're going to look at today is let's put them together. Let's put them together. So let's say I have 3.72 grams of carbon dioxide. And I want to know how many particles that is, so molecules. So the first thing I need to do, according to my mole tool, is I need to go from mass to moles, and then I can go from moles to molecules. See, I have no way of going from mass to particles. So I have to go from mass to moles, and then from moles to particles. So I'm going to go, first I need the molar mass. I need the molar mass of carbon dioxide. So I have 1 carbon and 2 oxygens. So that's 12.01 plus 32, 44.01 grams per mole. All right, So my conversion then is 44.01 grams of CO2 is equal to 1 mole of CO2. Now I'm going to start with my 3.72 grams of CO2. That's what I'm given. So I don't have anything else I can start with. I'm going to start here at mass. I'm going to go to mole using my molar mass, and then I'm going to go to molecules using 6.02 to 1 mole. All right. So my grams go down here, 44.01 grams of CO2 to 1 mole of CO2. And now I can cancel out my grams. And what I want is I want to go to molecules. So can I get from moles to molecules? I can. 1 mole of CO2 is equal to 6.02 times 10 to the 23rd molecules of CO2. So now I cancel my molecules and I'm left my moles, and I'm left with molecules. So on my calculator, I'm going to say 3.72 times 1 times 6.02, which obviously you don't have to do the 1, to the 23rd, equals. Then I'm going to say divided by 44.01, and then divided by 1. So I'm multiplying across the top, pressing equals, and then dividing out the bottom. 5.09 times 10 to the 22. Molecules of CO2. That's what I get. Okay, now what if I want to do one backwards? So instead, I have 6.23 times 10 to the 21 molecules of CO2 is equal to how many grams of CO2? So I'm going to start with my molecules, 6.23 times 10 to the 21 molecules and I'm going to put my box. Molecules go down. How many? 6.02 times 10 to the 23rd molecules of CO2. And see, I'm starting here, so I'm going to go from molecules to moles, and then from moles to grams. 1 mole of CO2. And then I can cancel out my molecules, and then from 1 mole of CO2, right, I go to 44.01 grams of CO2. And I cancel out my moles, and I'm left with grams. So then my math here is going to be 6.23 E21 times 44.01 equals, divided by 6.02 E23. 4.55 times 10 to the minus 1. Grams of CO2. Okay? All right, so we've done a few things. Now you're going to go on Canvas and use a textbook and do your homework. And that will be that for today. All right? Oh, before you do that, remember to put your mole tool on your periodic table. So do that now. Put your mole tool on your periodic table.